Sometimes we need to update the caches. For instance, we may decide to cache some extra files on installation. Or we may want to split the caches into two, for example, a cache for JavaScript files and for all other files. And you should be aware of some possible difficulties when updating the caches. Firstly, we may run out of space if we add too much stuff to cache storage and IndexedDB, and therefore cached data may be suddenly removed by the browser. And secondly, we have to consider the complicated relations between service workers. One of the dangers here is that a new worker may delete or modify caches which are still used by an old worker. So we have to manage the caches properly. First of all, we have to version them. The general rule here is to create dedicated caches for each version of a service worker and to remove all unused caches when a new service worker is activated. It may sound a bit fuzzy at first, so let's try to implement this rule. First, let's add version numbers to cache storage entries. After refresh, the newly installed worker creates a new cache with the version number 1. Now increment the version. Refresh. Another cache is created. We also have to make sure that each service worker not only creates his own dedicated cache, but also consumes this only cache. Otherwise, there may be some confusion with files which are stored in different caches under the same names but with different content. Currently, in our fetch handler, we are looking for cached responses across all caches, across all versions that we have here, because that's what caches match do. Instead, we only want to traverse a cache with an appropriate version number. For that, we first get the specific cache using cachesopen. And then we call a match method on this cache. So now we are only looking for caches owned by a current service worker. This is more secure. And yeah, we have two match methods for basically one thing, and it's a bit confusing. We are cluttering the space with more and more caches, and we definitely don't need the old stuff owned by the terminated workers. So we really have to clean up here. The amount of space available for cache storage and IndexedDB seems to be quite large, but we shouldn't rely on that, and it's just a good practice to remove everything you don't need. Let's remove all caches before creating a new one. Cache Storage API doesn't expose a method to remove all caches at once, but there is a delete method to remove a specific cache by its name. So we will need to get a list of all names in cache storage and then remove the corresponding cache entries one by one. By calling caches keys, we get all names. And caches delete is to remove a specific entry by name. Now the first cache entry is gone. And that's how we can delete all caches. Again, I'll increment the version number. Hit refresh, and all the caches are gone apart from the latest version. Basically, we achieved the goal. Now we have dedicated caches for each service worker, and we quickly remove all the unused caches. But removing the caches on installation is a bad practice. It's not a huge problem in this particular case because we call skip waiting here. But what if we didn't? It would mean that a new service worker installs, kills the old caches, but the old worker still controls the page and it relies on the old deleted caches. So we shouldn't just delete all caches on installation because we don't always skip waiting. We may remove the old caches only when we know that an old worker was already terminated. Unfortunately, we don't have anything like terminate handler. But we have an activate handler and it solves the problem just as well. because the activation of a new service walker guarantees that an old one was already killed forever and will never intercept any requests. So let's move this block of code to the activate handler. And of course, this time we want to delete all caches except the one that was just created by a new walker. Now basically we have the same behavior as before. We keep only the latest cache. But this time the old walker is better protected from unexpected removal of its dedicated cache. Let's see it in action. I'll remove skip waiting to make it more visible. And increment the version. After refresh, a new service walker is installed and waiting. At this point, the new cache is already created, but the old is still alive. And only when I click skip waiting and the new walker takes over, it removes the old cache. And I think it's a good time to introduce another boring but necessary syntactic feature of service walkers, or I'd rather call it a syntactic problem. So we have this event waitUntil method. As Mozilla explains it, waitUntil tells the event dispatcher that work is ongoing. If you are curious, you may try to read this and understand what it means. But I would recommend to forget this definition and just use this method when we need it. We need it inside an install and activate handlers. We have to wrap all the asynchronous work in a waitUntil call like this. So far my code worked absolutely fine without waitUntil, because it handles some weird edge cases which are really hard to reproduce. But still it's a recommended way of doing things. So we have to call waitUntil with a promise, which is a result of everything that we did in this activate handler. But we don't return anything from this callback. We are deleting all the unused caches here, so we have to return a bunch of deletion promises merged by promise all. And of course map instead of for each, because we need an array of promises. And return a promise for every deleted cache. So I guess now we may rest assured that an old service walker won't be terminated until all its dedicated caches are removed. And let's be consistent and use waitUntil on installation as well. All we have to do here is wrap everything in waitUntil. By this we tell the browser that installation isn't complete until this add all promise gets resolved. And it prevents something terrible from happening, though frankly I don't know what exactly may break here. Great, now it seems to be compliant with all best practices. Service walkers exploit only their own isolated caches and all the unused caches get deleted quickly and safely.